Hi everybody, my name is Ambra.
And mine is Antonio.
We are here to present our exoplanets panel, realized by the students of the class 5SC in collaboration with our math and physics teacher, Roberta Fantini.
The research of exoplanets is a very recent discipline. Just think that the first extrasolar planet was discovered in 1995. Although it has passed just 20 years, this research of astrophysical field has obtained excellent and surprising results, a fact that reveals its importance in the number of exoplanets discovered today, which coincides with 3,726. How many planets like our Earth are in the galaxy? The current answers to this question are given to us thanks to particular instruments that use indirect methods of revelation, such as the transit method and the radial velocity method, both used by Kepler telescope.
Kepler is a NASA space mission whose purpose is the search of Earth-like planets orbiting stars different from the Sun. To do this, a photometer constantly monitors the constellations of the Swan, the Lyra, and the Dragon. The data are transmitted to the ground, where they are analyzed in search of periodic decreases in brightness of the stars caused by extrasolar planets passing in front of them. The transit method can be explained by a simple metaphor. Consider a light bulb. It needs a clean glass to work well. If it is dirty, the brightness drops from its maximum level. A similar procedure takes place for the identification of an exoplanet. When it comes between the star and our point of view, a portion of the star's brightness is blocked, just as dirt does on the light glass. If during the observation the brightness decreases, depending on the volume of the planet, and after a period of time it returns to the level of before, the star is likely to present an exoplanet. The main directives of this research field are, on one hand, to determine physical structure of the exoplanetary systems, and on the other, to measure the internal composition and the chemistry of the exoplanets' atmospheres that can then be studied in detail in search of biogenic gases.
Two of the most important astronomical projects of this decade will carry out this new frontier, JWST and the EELT. The great potential of these two tools will allow the research for biomarkers like oxygen in the atmosphere of the nearest extrasolar planets. The observation of the James Webb Space Telescope will focus on some topics of great importance, such as a better understanding of the origin and evolution of galaxies, an in-depth analysis of the birth and formation of stars and planets, and the study of conditions for life. This suggests a great contribution that the telescope will bring to exoplanetary research. In fact, using the transit technique and the study of radial velocity, we can estimate the masses of exoplanets, while spectroscopy and the relative study of data will lead to the identification of particular chemical compounds of which the atmospheres of the planets are formed. In particular, Webb will search for traces of ozone which, being linked to the presence of organisms, can be a possible indicator of elementary life.
To conclude, we mentioned the importance of the Galileo National Telescope, property of the Italian astrophysical community and really important in this field of research. We follow up this occasion to advise looking Galileo's panel, one of the most important scientists ever, who this instrument is dedicated to.
We hope you enjoyed the video and that you feel interested in this topic. Bye bye.